In our last video, we covered how to Dockerize a Spring Boot application. We especially utilized a multi-stage build for that process. Let's quickly review that. Here is the project. I have opened it in IntelliJ IDEA. Here is our Docker file, and let's open it. Here you can see 3 distinct stages. This stage 1, downloads the dependencies. This stage 2 builds the application, and stage 3 runs it. If you missed that previous video where I explained this in detail, check the link in the description. Now, let's look at the configuration. Opening the application.properties file. Here, we are using MySQL database. You could absolutely use PostgreSQL or any other database. You would just need to make a few small configuration changes. Here is the database URL, then the username, password, and other configuration. We provided this environment variable to get this value from system environment. Okay, now let's spin up Docker container. I'll use the same command from before. I'm pressing the up arrow key to navigate through the history of the command. And here, this is the command to run this container. I have a detailed explanation of this command in my previous video. You can check that if you want to know more. Let's press enter. As you can see, our Spring Boot application is up and running. Everything started successfully. Let's test it with Postman. But before that, here, this is my GitHub repository. I have also provided this link in the description as well. In this repository, I have documented all the API endpoints. Here, this one is for getting all the products. This is the URL. Let's copy it. Now, let's switch to Postman. Here, we'll send a request. So, this will be get request. Paste the URL and send the request. Here, we're getting a response back. This response is a JSON array containing a list of products which are the items stored in our database. So, our application is running successfully inside the Docker. However, there is a limitation with this approach. Currently, our MySQL database runs in one container and our application is in another. Here is the Docker desktop. Here you can see this MySQL container, and this one is the container where the application is running. The main pain point here is that whenever we share this project with colleagues or try to deploy it to a server, we have to run or install MySQL separately and then connect it to the application. If MySQL is not installed on those machines, installing and configuring it can be a hassle. So what we're going to do next is package the database together with the application. What we want is a single command setup. A single command will make everything up and running. We can just use the app right away. This is where the Docker Compose comes into play. Docker Compose is a simple orchestration tool. It allows us to start, stop, and manage multiple containers together using one configuration file. I'll walk you through exactly how to package the MySQL database and the Spring Boot application together so everything works seamlessly. If you want the source code of the project, this is the public GitHub repository of the project. I have shared the link in the description. The repository is well documented, so it should be easy to follow along. Here again, I have this Docker desktop open. Okay, let's stop both containers. Now, let's return to the IDE. In the same directory where the Docker file and pom.xml already exist, create a new file. Name it docker-compose.yml. This Docker Compose file is where we'll describe all the containers that should run together. In Docker Compose terms, these containers are called services. So let's start by defining the services section. This is where we list all the containers that belong to our application. When we talk about services, we are really just talking about the containers that belong to the same application. In our case, we have exactly two services. a MySQL database container and our Spring Boot application container. So inside services, we'll define our first container. On a new line, at the service name, I will name it MySQL DB and add a colon. On another new line, I will define another service named app. This is the container that will run the Spring Boot application. Here, pay close attention to the indentation. MySQL DB is indented by 2 spaces. The same applies to the app. Both MySQL DB and app are direct children of services. So they must be indented by 2 spaces. Now I'll configure MySQL DB. For now, let's comment out this app service. Let's focus on the database. First, we need to define which Docker image to use for MySQL. I will add image, then colon, MySQL, colon 8.0. This tells Docker Compose to use MySQL version 8 from Docker Hub. When we run Docker Compose, Docker will pull this image automatically if it's not already present on our machine. Again, double check the indentation. This image line is a direct child of MySQL DB. So we need to indent it by 2 spaces. Next, we need to define the environment variables. We need to use those to configure the database user details. Without those, the MySQL database won't start. Here, this environment section needs to be at the same level as the image. First variable is MySQL underscore root underscore password. Here, provide a root password, something very secure. But hardcoding password in this way is unsafe, especially in production. Instead, we'll add it from system environment variable. Okay, let's remove this plain password. I'll show you how to set system variable later. For now, in this Docker Compose file, we can reference that system variable using a $sign and then curly braces. Inside the braces, provide the name of the variable. Let's say it is root underscore password. Okay. Next, add MySQL database. This is reference to another system environment variable. Let's define MySQL user. And finally, MySQL password. One thing I would like to mention, this MySQL password and MySQL root password are not the same. This one is for root password of the MySQL server and this MySQL password belongs to this MySQL user. Okay. Next, we'll add the ports section. This section is at the same level as environment. Here, I'll map port 3306 on the host to port 3306 inside the MySQL container. We need to configure these to access the database from outside the container. Without port mapping, the MySQL service is reachable only by the containers inside Docker. By exposing the port, we can now connect to the database directly from our local machine. For example, using MySQL Workbench or any other database client. Now, for the volumes, I will add the volume at the same level as image, environment and ports. It should be the child of this MySQL DB service. We need to configure volumes to persist data. Without volumes, all database data is lost when the container stops or is removed. By using volumes, we can store the data outside the container lifecycle so it remains available even after restarts. Let's set the volume to /var /lib/MySQL. With this, I am specifying that MySQL data should be stored in this directory inside the container. This approach is called an unanonymous volume. In an unanonymous volume, we only specify the path inside the container. Docker automatically creates a directory on the host machine. This is where the application data will be stored. Because we have not specified the host directory, Docker manages the storage location automatically. It creates a directory within the Docker area on the host machine and assigns it a unique hash value. Inside that hash level folder, Docker creates a data subdirectory. And all MySQL data will be stored on that data directory on our host machine. However, in production, we typically don't use unanonymous volumes because they are harder to manage. In that case, we don't really know which volume belongs to which container. So, we will not use that. Another approach is to provide the path to a folder on the host machine where the container stores data. Something like this. In our host machine, inside home, in a directory named MySQL and then provide a colon. With this, we link a folder inside the Docker container to a folder on the host machine. Whatever data our application stores in the container folder will also be stored on the host inside this directory. The problem with this approach is that in a production system, it can cause permission issues. We are not also going to use that. For production, we typically use named volumes. Defining a named volumes is simple. Let's move the host machine path. Here, I am giving a name followed by a colon. And this will be act as the named volume. Now, to make this work for named volume, we need to declare the volume name at the bottom of the file as a top level element. So at the bottom, type volumes and as a child of the volume, give it the name. Once again, be careful with the indentation. This must be indented by 2 spaces. Next, I'll define a custom bridge network. This is a network through which our 2 services will talk to each other. At the bottom of the file, as the top level element, type network. With this keyword, I am telling Docker that I want to create a custom network. On a new line, as a child of networks, we can create a new network. Give the network a name, backend network. Now, we need to add another child to this, name. Here, provide the name again. Just copy this and paste it here. This ensures Docker Compose creates a network called exactly backend network. Next, we need to specify the driver for the network. Set driver to bridge. This creates a bridge network called backend network. Now that we have the network defined, let's add the MySQL DB service to it. In MySQL DB service, at the same level as volume and ports, add a new element, networks. Here, reference the network name we just created. This allows MySQL DB and our application to communicate within the same isolated network. And that's it for the database service. Now, let's configure the app service. I am uncommenting the app. Here, this app represents our Spring Boot application. Here, we could define an image just like we did for the MySQL DB service that is specifically useful if we hosted this image on Docker Hub. However, we want to build our own custom image. Since we have a Docker file to build our own image, I want to use that. Instead of specifying an image, we'll use build. Provide the folder name where the Docker file is defined. I am using a dot because the Docker file is located in the same directory as the docker-compose.yml file. Next, define the ports. Map 8080 on the host to 8080 inside the container. With that, we can access our Spring Boot application using this port. Now, let's configure the environment variables. Open application.properties file. Here, for configuring the database, we have used these environment variables. We can set the values for these variables in the Docker Compose file. Back to the Docker Compose file. The first environment variable is db_host. Here, we need to provide the address where the MySQL container is running. Since this container will use the same bridge network, we can simply refer to it by the service name, MySQL DB. Then let's add DB port. I think I need to refactor the application.properties file. Here, instead of hard coding the port, I'll use the environment variable. Wrap this with curly braces, add a $sign, name the variable db port, and add a colon. Now back to the Docker Compose file. For db port, provide port number 3306. Then provide db name. Let's copy the variable name of the db name from MySQL db service and paste it here. Now let's check the application.properties file again. Here we have defined db schema. Let's rename it to db underscore name. Back in the Docker Compose, now provide the system environment variable name db user and db password. Now our next element is networks. It's backend network. Now our Spring Boot application needs to connect to the database when it starts. If the database container is not running yet, our application will fail to connect and eventually it will fail to start. We need to ensure our database server is up and running. So here we need to add a depends on section. Our application depends on MySQL DB. With that, our app container will start only after the MySQL container is started. However, there may be a situation where the MySQL container started first but still needs a few more seconds to initialize. It is possible that MySQL takes longer to start while Spring Boot starts sooner. In that case, because the MySQL server is not ready yet, our application will fail. To avoid this race condition and ensure the application waits until MySQL is fully ready to accept SQL queries, we will use a health check. First, let's add a new condition to our app service in the depends on section. As a children of this element, this service name, we need to add a condition, service underscore healthy. Now, our app service will start only after MySQL DB reports its status is healthy. This makes Docker Compose to wait to pass the health check before creating the app container. For this to work, we must define a health check in the MySQL DB service that proves it is ready. In the MySQL DB service, at the same level as networks and volumes, let's add a new section, health check. Here we'll define how to test if the MySQL container is healthy. Add test as a child of health check. Here we provide the command for checking the health in an array format. Something like this. First parameter, cmd-shell. This instructs Docker to use container shell to run the following command. Next element is the command itself, MySQL. This is the client tool that comes pre-installed with the MySQL Docker image. Since we are inside the container, this client can connect directly to the MySQL server running there. Then use -h for host, provide the host address. Since we are inside the container, we can use localhost, or we can also use the IP address representing the localhost. Then provide the user credentials. Use -u for user, and here I am going to use the environment variable db_user and then the password. With this, the client will authenticate using the credentials we provided. When the authentication is successful, we'll run a small SQL query. Select 1. This is the simplest possible SQL query. It does not read from any table. It just returns the number 1. This is a common approach to implement a heartbeat check. If it returns 1, our server is up and running and able to accept connections. Then I'll add an interval of 10 seconds. This tells Docker to run the health check every 10 seconds. Then add a timeout of 5 seconds. This sets a limit. If it takes a longer than that, it counts as a failure. Next, add retrace to 10. This means Docker will allow up to 10 failed health checks in a row before marking the container as unhealthy. Finally, add a start period, set it to 45 seconds. This gives our container 45 seconds of warm-up time before Docker starts counting failures, which is helpful for database that needs extra time to start. That's all for the Docker Compose file. Now we'll build and run this. But first, we need to set the system environment variables. As we configure Docker Compose to read them, we must provide values. There are a couple of ways to set the environment variables. One option is setting them via the terminal. The method differs depending on your operating system. For example, on Mac or Unix systems, we can set it this way. Export, then the variable name, something like dv_name equals, and provide the name. For Windows, I believe instead of export, you may need to use set. Since I have not been using Windows for a long time, I am not sure about that. But you can find plenty of suggestions. Even you can use ChatGPT to identify that. Here, since I am using Mac, I will use export. If I press enter, the variable will be set. However, this variable only exists for the current terminal session. If you close the terminal, the variable is lost. A better approach is to store those variables in a separate file and pass that file to Docker Compose. Let me show you how. In the same folder where the Docker Compose file exists, let's create a new file. This file will not have any name, only the extension .env. Any file named just .env is considered the default environment variable for Docker Compose. Let me add this to gitignore so that I do not accidentally commit sensitive information to GitHub. Now, in this .env file, let's set the variables. Root password, another one is dbname, dbuser, dbpassword, and dbport. Now, let's set their values. Okay, now let's start everything up. Open the terminal. To run the Docker Compose, the command is docker compose up. Here, the Docker is starting. Here it is running the MySQL, and now our application. So it has finished starting. Our application has started at port 8080. Here in the Docker Compose file, as we have mapped the container port to host port 8080, so we can access it using that port. Let's test the application. This was the request to get the list of products and send a request. Here in the response, we are getting an empty array. That's because this is a fresh MySQL container, so there is no data saved. Let me show you. We can access the MySQL container from the host machine. Here in MySQL DB service, we map this port so we can access this externally. To inspect the database, I'll use the IDE's built-in database tool. I am using IntelliJ IDEA, but you can use tools like MySQL Workbench or any other tool that you prefer. Click on the database icon, then the plus icon, then data source, and choose MySQL. Here we need to provide the credentials. Our container is mapped to port 3306, so we can use that here. Provide the username and password. Here I'm clicking test to check if it's worked. Great. It's connected successfully. Click OK. The database connection is showing here. Let's expand this. Here, click on these three dots and choose the database. This one, product DB. Here, our schema is visible now. Expand the tables. At this time, we have only one table, products. Double click to check the data. See, we don't have any data stored. Let's add a product. Back to GitHub repository. Here, let's check the request we need to send to add new product. Here is the API endpoint for adding new product. And this is the curl request to create a new product. Let's copy this. Back to Postman. Open the sidebar. And click this import and paste the command. I'll import it without saving. So here is the request. This is the post request and this is the URL. And here is the body of the request. Send the request. Okay. The status code is 201. So the item is added. In the response, here is the product information. Let's check in the database. Refresh. Here, the new product is added. Great. Let's check it using Postman. In the previous step, where we check the list of products, send a request. Great. We have the product in the response. We have successfully used Docker Compose to Dockerize our Spring Boot application and database together. We can now safely share this with others, allowing them to run the application with one command. But there's one last detail I want to cover. Open the sidebar. Let's copy this environment file and paste it into the same folder. I'll name it .env.example. Here, let's update the variable with placeholder values. Now, I'll commit this example environment file to the GitHub. So, when you clone the repository, you will get this file. You just need to rename it to .env, remove this example part, update the credentials and use it. Okay, if you're still watching, thank you very much. You did a great job. In the next video, I'll show you how to deploy a Spring Boot application to a live server completely free. Please keep an eye on my channel. See you on the next. Bye bye.